Hey, good morning. So today we are taking a look at some of those proteins on the surface of the cells that we were talking about in our last lesson. We're going to look at a very specific example today. With blood antigens. So you've probably heard of blood typing with types A, B, and O. And all of those have to do with surface proteins on the surface of the blood. So your type of blood, what type you are, if you've heard your A type blood or B type blood or O type blood, it all has to do with the type of antigen on your red blood cell. And an antigen is a peripheral protein. So that's what we were looking at a couple of days ago. Now, these are not the only antigens. There are thousands, maybe even millions of antigens on different types of cells. For example, flus, there's a lot of different variations or variants of the flu. And the biggest difference oftentimes is what type of antigen or peripheral protein they have on this side of the virus. About 10 years ago or so, I don't know if you guys remember the H1N1 scare, the swine flu scare. Well, the H1 and the N1 were each the H1 antigen and the N1 antigen. They were each different antigens. A lot of times when you have a flu vaccine, what that is they will inject antigens into you, and your body learns to recognize those antigens. And so if you ever become infected with the flu that has those particular antigens, your body already knows how to fight it, recognize them, and get to work fighting them. So we're just looking at one specific, well understood and well demonstrated example, and that's blood type antigens. All right, there's three distinct types of antigens on any blood cell. We have the A antigen, the B antigen, and what's called the Rh factor, the Rh antigen. Going along with antigens are antibodies. Now spend some time making sure you guys are comfortable with the difference between these two words. They look and sound similar, but you need to know the difference between antigen, surface protein, and antibodies. So antibodies are free floating. They don't necessarily have to be free floating. They can be attached to different cells as well, but they're generally free floating proteins that kind of flow around in your blood, and they recognize foreign antigens. Any antigen that is not a part of your body, these antibodies will recognize it and kind of send up the signal, hey, destroy this thing. We've got an invader. We're in trouble. And that's the job of antibodies. And in general, it's a really, really good system. All right, so we've been talking about proteins for a while now. Proteins have a very specific shape. So you just notice I got the semicircle there for an A antigen, a square shape for a B antigen, and a triangle for an Rh antigen. That is not necessarily the shapes that these antigens have. In fact, it's almost certainly not the actual shapes, but kind of easy enough shapes to see and recognize. antibodies do look like a Y. And that shape is actually really, really important. Then on the top, these are actually interchangeable. So an antibody itself is kind of the Y, but then on the top, we can put different shapes that are, and these again, these are interchangeable depending on what season it is or what the virus you're currently fighting is or whatever. We can change out these different shapes that are now designed to recognize the different antigens. All right, so that Y shape is really, really important. So that Y shape allows antigens to grasp, latch onto. So you can see kind of the shapes here. Boy, it's a tough Y to make. So here's one antibody. It's grasped onto two antigens of different cells, and here we'll draw another one. There's another one with that Y shape, and again, it's holding on to two different cells. So that's really important. And that's kind of why these antibodies have these different shapes. They can grasp a bunch of different cells, and that kind of like throws a net over your foreign bacteria. If you have a bacterial infection, you have a whole bunch of bacteria, you kind of throw that net over them, and you get a whole bunch of antibodies that catch the antigen and keep them all in one place. And then they send up a message also. So they send up a message, hey, WBC, which stands for white blood cell. They're our body's disease fighters. They're going to come around and almost literally chew up and spit out these cells. So, hey, white blood cell, come kill these cells. Come destroy them. They're foreign to us. We don't want them. Come kill them. And again, keeping them all in one place is good. Now you don't need as many white blood cells. It's not like we need to go chase down a whole bunch of spread out enemies. They're all kind of stuck in one place because the antibodies kind of clumped them there. And that's called agglutination. When that happens, and to the layman, that is clumping. Now, normally that's a good thing. Again, if you have bacteria or a virus, you want to keep them all in the same spot. And so what your antibodies are doing is really a very good defense mechanism to kind of round up and corral all of the foreign cells. Unfortunately, it also works with blood types. When you have a blood transfusion, when you receive someone else's blood, if you have the antibodies to recognize someone else's blood, you're going to have this agglutination and this clumping, and that's generally going to lead to death. That's strokes, that's heart attacks. That's really, really bad. So it's really important to know your blood type and to make sure that in a transfusion, you don't get the wrong blood type. Now, don't stress it too much. Hospitals are really, really good about figuring out your blood type and making sure that they give you the right blood type. But again, this is why. All right, I'm gonna build a little column here and take a look at it. All right, so we've got 4 different types of blood. And as I said when we started, the type of blood that you have is all dependent on the type of antigen found on your blood. So A-type people, not personality type, but people with A-type blood have A antigens. Oops. All right, so the antibody, people with A-type blood, you don't want to make the same antibody. Remember, if you have an A antibody, that would mean you're going to have clumping and you're going to die. So you don't want your antibody to match up with your antigen. So people with A-type blood have B antibodies. So again, their antibodies won't match up with their blood. So they'll be okay. They'll be safe as long as they have their own type of blood. Another blood type is type B. People with type B have the B antigen. Again, the type of blood that you have is determined by what type of antigen. So B antigen on B-type blood, A antigen on A-type blood. Same with the antibodies then. We don't want our antibodies to match up with our blood. So if you have B-type blood, you have the opposite antibody. You have the A antibodies. And then that circle shape is not going to match up with the square shape. Next type of blood is AB. Hey, you've been playing along. You know that, again, the blood is named for what type of antigen is on the blood. A has A, B has B, and I'm guessing you know already, AB has both. A and B antigens. It's got the circles and the squares. How about the antibodies? Again, we don't want our antibodies to match up. So these would have no antibodies. Well, no A or B antibodies. They have other antibodies. Again, these antibodies, we use them to recognize a lot of different antigens on a lot of different cells, bacteria, viruses, other cells. So the blood types are just one specific example. So I don't want to just say no antibodies. You're still going to have plenty of antibodies if you have type AB blood. You just don't happen to have A or B antibodies. Finally, then the last type of blood is type O blood. You think of the O as more of a 0. Why a 0? Because there are no antigens. Well, no A or B antigens. So these cells are naked, no proteins on the surface. Antibodies, well, they have both antibodies. Both antibodies on type O blood. All right, so when you're taking a look at this, if you have type O blood, who could you receive blood from? You couldn't receive type A blood. Someone with type A blood couldn't give you that. You'd recognize it. You have the antibody to recognize it. You couldn't receive type B blood. Again, you have the antibody to recognize it. So you couldn't do it. Definitely couldn't get type AB blood. You have the antibodies to recognize both antigens in that one. So the only type of blood you can receive if you're type O is other type O blood. How about if you're type AB? If you have type AB blood, whose blood can you receive? Well, you're safe with A. Look, you don't have the antibodies. You're safe with B. You don't have the antibodies. You're definitely safe with AB. Their blood's just like yours. And man, you're doubly safe with type O. There's no antibodies. I'm sorry, you have no antibodies, excuse me. And there's nothing on that cell to recognize anyway. So yeah, go ahead. Take blood, take blood, take blood. Type O is known as the universal donor because it doesn't have any of those proteins on it. No other person, no other type of blood is going to recognize it. Type A, people with type A blood, there's nothing to recognize. Type B blood, nothing to recognize. So type O is known as the universal donor. All right, just one more quick line to add to run out of room on that bottom part of the paper there. There's one more. We started off when we listed those 3 types of antigens. There's one more to talk about. All right, so Rh factor is the 3rd type of antigen. Instead of saying we are ABRH or ARH or ORH, we just say positive or negative. So O positive, O negative, and the positive or negative refers to whether or not you have the Rh factor, which again is that 3rd antigen. So people who are positive have the Rh factor, they have the Rh antigen, and they don't make antibodies. People who are Rh negative do not have the antigen and do have the antibodies. So it works the exact same way. And if you have the antigen, you don't want the antibodies to match up. If you don't have the antigen, you have antibodies that recognize blood that isn't yours. So it works the exact same way. And that, again, that ultimately gives us 8 types of blood: A negative, A positive, B positive, B negative, AB negative, AB positive, O positive, and O negative. All right, well, we had a pretty cool lab. I think you can probably, if you missed it, you can probably take a look on Canvas and do a lot of it just from Canvas. So that, though, concludes the notes for today. So have a good tomorrow, and we'll see you next time.